This video looks at sectioning, and this is the drawing that we are going to be covering in this session. So the question says, the figure below shows an isometric drawing of an object. Produce an orthographic projection of the drawing showing the sectional front view through XX. Okay. This should have been sectional front view through XX. And an end elevation here seen from the right, and a plan. So that is the first part of the question. The second part is also produce a sectional isometric drawing of the object through XX with the front elevation in the left isometric plane, and then we can use hashing for the section. Okay, so yeah, in the second part we would produce an isometric drawing, but the front elevation should be in the left isometric plane. Okay, so in this drawing, the front elevation, the one shown by the arrow, is in the right isometric plane. So we need to draw this drawing in a different orientation where the front elevation is this side, which is the left. And also we are required to only draw a sectional view. So as seen from the front, we need to draw the sectional view of XX. Okay, yeah, so before we go ahead with this drawing, let me first explain a few basics about sections. Alright, so sections and sectional views are used to show hidden details more clearly. Okay? So before we've been representing hidden details with some dotted line, but with this now we can draw sections or sectional views or sectional views to show the hidden details, usually the interiors of an object, or to clarify a particular point on an object. So sections and sectional views are created using a cutting plane to cut through an object basically. And the difference is a section is a view of no thickness and shows the outline of the object at the cutting plane. So visible outline beyond the cutting plane are not drawn. Whereas a sectional view, on the other hand, the visible outlines can be seen beyond the cutting plane. Okay, so sections and sectional views are important and so on, because of what I've already told you earlier, showing hidden details, details of how hidden lines appear. Okay, especially when an object cannot be properly described by pure orthographic projection. So we include sectional views and section views. Okay, so I'm going to skip all this and go ahead to simply show you that if we had such a drawing and the interior is a hollow part which is indicated by hidden line, so we would include a section. This is a third angle drawing of this same object. So a sectional view would have to put a cutting plane. So in the front elevation, we represent a cutting plane by simply a line to show a cut through the front. And if we need to show a sectional view as seen from the left, because this is a third angle, so a sectional view seen from the left, we will see this entire object minus this part. So that is what the arrows indicate, that after cutting we will be left with whatever is in the direction of the arrows. Okay, so this is a cutting plane, and once we cut, we get rid of this and we want to show what is visible after cutting. So we'll be able to see this edge along the cutting plane and we'll be able to see that part. Okay, that is, if you stand on the left side of the object, you'll be able to see a cutting plane from there to there, and then the top part you'll be able to see a bit of it, remaining bit, which is this one. So normally what we do, if any object has been sectioned, the section part is shaded. Okay, and the shading is usually done with section lines. So now these are what we call section lines. Okay, this is a cutting plane, and these are section lines. Whatever you use for shading or hashing. Okay, same thing here. This is a cutting plane, the whole of that. Then whatever these are section lines. And when you are drawing with pencil and paper, you usually have to draw them at 45 degrees to the horizontal. But now with the computer, you don't have to worry about that. You just look for the hashing tab or tool, and you add whichever hash you want to appear at the section part, at the section. Okay, so now only this part which is shaded is what we call a section. But if we are to include the other details of the object, or what is left after cutting the object, then we would call it a sectional view. But if we were to draw simply this shaded part, then that would be a section view. So that's the difference. Okay. Yes. Okay. So we've got an object, the isometric drawing of the object, then a cutting plane. The arrows are just to show the direction that is left, the direction of, rather the view of the remaining object. Okay. Or whatever object remains after cutting is shown by the direction of the arrows. So wherever the arrows are facing, that is the part left after cutting the object. So that is the cutting plane, and this would be a sectional end view as seen from the left. Okay, yeah. So if we didn't have the top part, if we only drew the shaded part, then it would be a section view. Okay, a section end view. And of course this is the plan, because this is third angle orthographic drawing, orthographic projection. Okay, so I think that is enough about that. You can look at the various we have the various types of section views. Okay, full section, offset section, half, broken half section, and so on, auxiliary sections. Okay, yeah, there are various sectional section views, various types of section views. So yeah, you can check those ones out. So what we are going to look at is this drawing. Okay, so this is what we are supposed to look at as the isometric drawing. So first part, we're going to cover the first part, and then the second part will be covered in the next video. So all we have to do is to produce the orthographic projection of this, and instead of drawing a full front elevation, we're going to draw a sectional front view through XX. Okay, so whatever is left after cutting off this will be the back part of this. Okay, so yeah, now heading over to AutoCAD. Okay, so heading over to AutoCAD, this is our drawing. Okay, it's actually the same drawing, only that now the front elevation is facing, the front elevation is in the left isometric plane. Okay, yeah, although whatever is here is not what is required even in the next part. So this is just to illustrate what the other part would look like if it were complete. The sectional isometric view would look like if it were complete, and that will be for the next video. So for this video is what is required is the orthographic projection. So we are going to use these same dimensions, and lengthwise our drawing is 50 by 16 by 50. Should be the same here, 50 16 50, then 23 16 23. That is for the plan, and then the height still to do with the front elevation will be 16 by 16, 32 and 16. Then this is to do with the plan, so that will be 62 and 26. Okay, so yeah, I just changed the background color from black to white. I'm hoping that will work. So we'll go over to layer 0 and get the line tool. So make sure the ISO of I'm not supposed to be using the ISO plane, so make sure the ISO plane or the ISO drafting is turned off. First escape, then turn off the ISO plane like that. If they are not colored, then it's turned off. You would see by the grid would be like this. If it's turned on, then the grid changes like that. Okay, but today I'm going to work without the grid. It's not really important, it's just for your peace of mind, but you don't have to work with the grid on. Yeah, so I'll start off by drawing the front elevation, and we are using first angle, so you don't have to worry about any other thing. So basically we are using first angle, so I'll type 50, then 16, then 50. Okay, then I'll go up by, let me look here, by 16, 20, 32 and 16. Okay, now going back here, I'm going to go up. Make sure the angle is 90 degrees, so up by 16, 32 and 16. Okay, so now the rest you can use tracking. You don't have to measure anymore, you just track the angles, 180 and 90 degrees. Just track the angles. Okay, then we do the same thing for okay, now we start partitioning our object. Okay, so we need to indicate 16, there's a 50, then 16 and 50, so we have to project lines to clarify what is there. Okay, yeah, because this is our front now. Okay, so we need to partition here and also partition there, then we figure out a way of drawing the top part. Okay, so that should be very easy. We've already partitioned because we had, okay, first of all let me turn off midpoint. I don't need midpoint. So line tool, somewhere here I have 50, my first endpoint, so I'll draw it to a point that I have I should have 16 and then 32. Okay, so I'll only draw it to the point of where I had 32. 32 was somewhere there. I had 16 and 32, so I'll just track and connect like that. Then this is 16. Okay, there's a something there that is 16, so I'll track the 16. It's around here, so I'll track it and I'll have 0 degree and 90 degrees, so click then to that end point. Okay, it's better than drawing all those unnecessary lines. Okay, now the other thing is I'm going to draw sorry, I don't have to go there, I have to look at this. So I've just drawn this part here, although it reaches far down here, so it shouldn't go as far as down there, but we can always delete those lines. So I'm going to draw this part. This is simply 16. We've already put we've already partitioned those lines, so I don't need to measure anymore. I just have to draw, and I could as well move this here. Okay, I could just move it there instead of deleting the lines. I could just move it there. It's the same thing. So now before I draw the slanting part, I have to sorry, I keep going back to that drawing. I'm supposed to look at this for reference. So before I draw the slanting part, I should draw the top bit, which is a cuboid of some sort. So it's 62 by 26 by 16. So I only need 62 and 16 because I can't see the 26 in the front. And what I'm going to do is it's exactly in the middle, so what I'm going to do is to use a calculator and what did I type? So I'll use a calculator, and originally we had 50 plus 16 plus another 50, so that is the length, the maximum length of the object. So I'm going to subtract the 62, so minus 62, and then whatever I have left I'll divide by 2 to get the part which is on the extreme end, or whichever part I'm supposed to cut off. So that is equal to what did I do? It was 54, so yeah, that was 54, so it was 106, so minus 62, so I have 54 now. 54 divided by 2, I should have 27. Okay, so from any end point I'll draw at a distance of 27 as my starting point. Then I go downwards by, remember that distance was 16, and that should touch that point. Okay, yeah, it should, but I'm not going to do that. I'll just type 62 to reach the farthest point, and then continue upwards to okay, continue upwards. I'm failing to track that intersection, so I'll just recreate that line there. Okay, so we no longer need this and this and this, and we can delete those, and yeah, and go from there. Okay, you can just reduce this to that point. Now what I'm left with is to draw a line from there to there for the slanting face, and another line from there to that end point. This should be at the end point, so you make sure it's exactly at the end point, not at any intersection, so make sure you're using end point. Okay, so this is what it should look like, the front Now this corner, there's a corner point here. We can't see it in the front elevation. Okay, so that is how the front should look like, but we are actually interested in the sectional front elevation, right? So what I'm going to do is to project the lines downwards and produce a plan. Then I'll have to rub off these because they are not required, and this as well. Okay, yeah, ideally you should start with a plan, project the lines upwards, and then produce a sectional front, whichever makes life easier. Okay, but yeah, in the end you end up with the same thing. So I'll continue with my lines downwards. Maybe let me first outline this, outline that, and then we continue with so I'll just project lines down from every end point. Project the lines, vertical lines, project the vertical lines, and yes. Okay, so I'm no longer using that axis to separate between the views. Instead I'll use an equal distance between the views. Okay, the idea is the same. So what I'm going to do is to use a distance of 30 in between. So that my plan starts at 30 from the front. And my plan is 23, 16, 23, like that. So 23, 16, and 23. Okay, so what I'm going to do is this. I'll start from here and go down by 23 to get that point. Then 16, get a starting point at 16 from that point. Then the last point should start at 23 from the previous point. Okay, so now how is the top going to look like? Yeah, now the top part is 62 by 26, so we need to place 26 exactly in the middle of 23, 16, and 23. Okay, so that should be fairly easy. Still use a calculator. We have 23, 16, and another 23, so that gives us 62. So minus 26, we get 36. So divide by 2, we should have 18 on both sides. Okay, so let's go back to AutoCAD. Get your line tool, and you're going to measure 18 from any of the endpoints. So 18, get your starting point, and actually I should put it exactly along with that top part. So I'll do that again. I'll use this intersection and go down vertically downwards, distance of 18 to get my starting point, get that intersection, and then from this I should go down a distance of 26 to get that point. Okay, so I hope that math is making sense. Okay, yeah, now the plan is actually finished. All you have to do is we can go over to the outline layer and use the line tool to just draw around it. Draw around, make sure you're using endpoint, you're tracking the endpoint. Otherwise, sometimes intersection doesn't give you what you are looking for. So track the endpoints. Now for the other bits, we have this one. So I'll just draw continuously, then I'll delete the lines. Okay, so I can delete this one, then there, and there. So I can delete Ctrl Z. So I can delete this one, I can delete that one. So same thing, draw here to that point, then those 2 points, then we can delete that one, then finally draw from there to there to there to there, then delete this one. Okay, so we can get rid of these other lines as well. So as not to make too much confusion, so we can get rid of those lines. So this is how the plan appears. Okay, so for our sectional, for the section line is exactly in the middle. And maybe before we continue with that, let me get rid of this and that and that, and this won't be visible, obviously this, yeah, so I'll be able to see something like that. The sectional front view is going to appear like that, yeah, because if we cut along the middle, whatever is left is going to be just blank like that. Okay, so before we shade that, let's complete an end elevation of it, and for that we go back to the to layer 0, project lines as far as they can go, project lines as far as they can go, and project as far as they can go, and also project that line. And yeah, so we're going to start off with at a distance of, we use 30, so we should maintain the 30. So I'll type 30 to get the starting point, then all the way to that point is enough. So the distances for the end elevation should be taken from the plan. So I'll measure, this was 23, 16 and 23, I hope. Let me check here. So the end is actually this face, what we are going to be seeing here. That is our end. Okay, so probably I could hash it out for you. Okay, I could hash it out for you, so we could see what the end view is going to be, and this and that. Okay, yeah, so this is the view from the right. The right side, we'll be able to see that, this and that part. Okay, so I'm going to draw and make sure that this is what we see. So that is the right our view from the right. Okay. Okay, so it means I need this distance, this whole distance at the bottom, 23, 16 and 23. Then I need 16 going upwards. Then of course I'll need 32, the length of that, the vertical distance from this point to that point. Okay, so now I'm taking the vertical distance, not the true distance. The true distance is slanting, and the true distance is the one seen in the front view. So that is the true distance. But the vertical distance is from here to here. Okay, it's different from the true distance. So in the end view, we won't be seeing the true distance. Instead, we will see the vertical distance. Okay. Yeah. So 23, 16 and 23. Then I don't need to measure the height because I already took lines from the front. I only need the distances taken from the plan. Okay. Yeah. So I'll look for 23. From there I need 23 and go upwards to that point. Then I need 16. From there along that line I need 16. So those lines don't even need to go as high as the last point, but yeah, 23 again. Okay, so that is the width of, or the whatever this end view. It should be from there to there, and it should be from here to here in terms of height. Okay, so for the top part again, the top, we should be able to see this from here to here, then down, then here, then back there. Okay, so we are basically drawing a rectangle at the top, and it's 26 by 16, so it's in the middle. So same thing as before, I'm going to subtract. If you still remember those dimensions, we are supposed to move 18. Okay. Geometrically we are supposed to project the line from here to there, then you move it via an angle 45. Okay, yeah, that is if you are using pencil and paper, but we can still do that instead of measuring again. So from there to there, now at an angle 45, that means I have 135 degrees. So I move along 135 degrees to that point, then I'll project the line upwards. Okay, I hope you see what I'm doing. So same thing with this point, project the line here, then at 135, make sure the angle is 135, look for that intersection, click, then go up and click. Okay, so it's done. Instead of measuring, you can just do that. So same thing with these lines. If I decide to connect this to that, if I connect that point to this point, the angle is going to be 45. Same thing here. If I connect this point to this point, because it represents that. Okay, well, yeah, anyway, let's go ahead and connect them, because most people get confused when it comes to orthographic projections. So I'll go ahead and connect these for you to show how they originate from the plan and how they originate from the front elevation. I'm not very certain about those intersections, so I need to zoom in and be sure. Okay, so I'll go ahead and connect this line to that point, right? But just for completeness sake, we can measure the angle and show you that it's actually 45. So I'll measure maybe this one and that one. It says 135, okay, because of that, okay. It's measuring from here to here, so that is 135. If you subtract it from 180, you end up with the 45, which is the angle I talked of earlier. Alright, so let us complete the end elevation by going to the outline layer, and we're going to draw now the top part. That top part, make sure you follow the lines. That is the top part. Oh, sorry. Get the line tool. That is the top part. So I'm drawing the top part first, from here to here, to that end point, to that end point, and there's that middle slanting bit which starts from there to there, to there, then that intersection. Make sure the lines are properly connected. You can always zoom in and out to make sure they are properly connected. So we can start from here to draw the final, well, not really the final bit, but part of the final part is drawing this, okay. Yeah, and what else are we left with? So far I've drawn, let me show you what I've just drawn. I've drawn this part, I've drawn the slanting bit, and I've drawn the base. So it's like we have an inverted letter T, but if we look at the right part, we are supposed to see this triangular bit also. It's not really a triangle, but it's almost a triangle, and it should be the same as whatever we have this side. There's a side that we can't see, which is hidden. We should have the same thing there. So let me go ahead and show you my hidden details of that. They are not very clear. Okay, they are, but they are a bit confusing. But there's that bit which is hidden there. See, there's okay, there's that bit which is hidden. It's more of a triangle, but not really a triangle. So we should be able to see it on both sides. Let me unselect that line. Okay, so that one, the selected bit, that selected part together with this one are supposed to be visible from the right. Okay, this is our right. So if I look here, I should be able to see that selected bit and this one. Okay, so I'll go ahead and freeze the hidden layer, because it's doesn't make visibility very good. So now that triangular, okay, not really a triangle, but that part is very easy. From the end, you just connect that point to that point. Okay, or just follow the plan and see what the plan tells you. This line comes from there to there, exactly there. It's in line with that line from there to there. So that is what you'll be able to see from here to there. It's like there are two lines in one. Okay, yeah, that line represents both of these lines, and whatever I'll draw the other side should represent both of these lines. So that's what I'm going to do. From here, I'll simply connect to that point. Okay, so I'm going to leave these lines there so that you can see the flow of the diagram. See how the diagram flows, or something like that. And maybe, yeah, maybe, just maybe, let me get rid of this and that. Okay, because they are a bit too much. Let me just get rid of those. Okay, so now this is our drawing, and yeah, that is the drawing. So for this part I'm going to hash it out. Let me hash. Just go to that. There's a drawing part, there's hashing, and you can choose several patterns. We can go with solid, or can try this, and well, it appears solid, so we can always change it to something else. They all appear solid because the view is the drawing is not that big. Okay, that's why they all appear solid, but they are actually not solid. So we can always click and edit. Okay, so we have hash editor, so we can always edit. We can choose a different hashing. I don't know what will bring out the details very well. Yeah, let's go with this one. Okay, let's go with that. You can go with that, or you can choose gradient. It doesn't really matter. You can choose steel. Now still appears solid, so we can go with the first one because I want you to be able to see those lines. Now those are what we call section lines. The one I talked of earlier, which are at an angle of 45 degrees. They are drawn at 45 degrees. So every other thing appears thick, so we can't use it. Okay, let's go with that one. Okay, let's go with that one. Okay, so we can go ahead and add dimensions. Yeah, and the thing about dimensions is that you don't have to repeat a dimension, or a dimension figure, or a dimension object. So if once we put dimensions on the front section of front, we don't have to put dimensions here, and same thing, we don't have to repeat that dimension on the end elevation. So go to the dimensions layer and go click annotate. Before you add the dimensions, first manage dimension styles, and usually you have standard, so modify, or you can create a new copy of standard, or whichever you want. So I usually use extend beyond dimension line 1 millimeter, so that is the small bit that extends beyond the dimension line, which is this one. So the offset from the origin, I usually use 3. This is the offset from the original point that you're trying to dimension, so that offset is 3. And symbols and arrows, I'm using the arrow size of 4, so it's able to stand out. That is the only setting there. Then text, we'll get back to text. First, every other thing, leave it the way it is. So go to primary units, and we can set the precision to 0 or 0.0, depending on whether or not you had fractional bits in your dimensions. But since we are using whole figures, whole numbers, we don't need to put 0.0 precision. So degrees is also at 0 precision. So the text usually standard by default, and the only thing you are modifying here is the text height, which is more like the font. Okay, the font of the text. Sorry, the font size of the text. And what we are using is ISO standard. Okay, so ISO standard is more like the aligned dimension. Okay, it's like how we use the aligned dimensioning system. Okay, So horizontal is the unidirectional system. So if you use horizontal, it's like you've chosen the unidirectional system, where the text is placed in the middle of the dimension line, and the text is always vertical. No matter how you are dimensioning that part, text is always vertical. So that is the unidirectional system, and the other system is the aligned, where the text is placed above on top of a dimensioning line. Yeah, so in order to achieve that, make sure you either click this, and then default is that, which will is like a mixture of some sort. I don't know what to call it, but that is usually default. So choose above, so click align with dimension line, and also offset from dimension line 1 millimeter, otherwise it will sit exactly on the dimension line. And we are using ISO standard, so just it's almost the same as align, but there's a slight difference with how you dimension the arcs and diameters, so that slight difference. Okay, so now you can click OK and close that, and now we'll go ahead and we can use aligned or linear, it doesn't matter, but we can use aligned. I'll click here and I'll click here. Okay. Alternatively, let me start from the bottom, the end points there, and also this together with this, but in line with that. Okay, so in line with that, and track that end point. Okay, so you see, then what I'll do is I'll track this point and that point perpendicularly, then I'll start from there, then I'll track this point along with that distance, the perpendicular perpendicular movement, and track that point there. Okay, so that's well, they don't really have to start from that point, okay, but here you can still tell what we are trying to dimension. Okay, it's the same thing. So for the plan, I'm going to dimension this point. We can always start from, it doesn't matter, we can start from there. Size 27, we don't really need the 27 per se, but anyway, it doesn't matter, so we can just show that that is 27. Okay, we can show that that is 27 from there to there. Where did it go? I should undo it. We can show that this is 27, and then we can show that we can show that from here to here is 50, and we can show that from that point to when we track that point there is another distance, which is 66, so we can always just do the subtraction. Okay, we can always just do that subtraction. Then we can also show that also show that from here, okay, from that endpoint to to this point, if I track it there, is that much. I think we are off by a digit, so I'll start over. From that endpoint to that intersection, we have something like this. Still says 89. I'm not very convinced, but I'll have to go with it. We could subtract and see if we are left with 62. Yes, so that is the right dimension. And finally, the whole thing. So now this is a progressive arrangement, that is 116. Okay, so for these points here, we can put them here. So we can do something like from here to here, that's 23. From here to here, that's 16. And then from here to here is 23. Okay, so this is the progressive arrangement. Okay, remember those dimensioning arrangements. So this is progressive. Start off with the smallest, biggest, like that. This is chain. Okay, so this is chain. If they're in line like this, then this is chain. Something here, chain. And what else do we need? We need to show that the size of this. Okay, the size of that. We can always put it somewhere here at the end. Okay, we can show it at the end. I didn't want to tamper with the end, but alternatively I'll just place it here, this side. Okay, so that we leave the end the way it is. So from here to here is 26. Okay, so the end is just like that. Okay, so you are done with the dimensioning, and now don't forget to add the cutting plane to show where we get this section from. Okay, so we need to show that. We need to show this line. Now we can only show it in the plan. We don't show it on the sectional view or on the section. We don't show this line. So that means we are not going to show it in the front elevation. Yeah, but we can show it in the plan, and we can also show it in the end elevation. Okay, so we could either show it in the plan or the end elevation, or whichever we choose. Yeah, so I'm going to show you where that cutting plane is. So I created a layer for it. It's that one, and I'll use the line tool to simply draw out a line from, it should be in the middle. So I'll go to midpoint and activate midpoint, then come back here, look for that midpoint and draw a line there. This line should stretch out to maybe to that point. So to that point, I will extend it to somewhere there. I'll extend it to that point. So same thing here. I'll get a line and look for the midpoint and put that there. Then I'll extend it a bit to around that point, and I'll extend this upwards. Okay, so now, yeah, the thing about cutting plain lines, we use a long dash and two short dashes. Long dash, two short dashes. It's a bit different from center line. Center lines is just a long dash and one short dash, long dash, one short dash. Yeah, but cutting plain lines are long dash, two short dashes, like that. So we need to indicate which direction of the view that we are left with, which part of the view that we want to cut away and which part do we want to be left with. So the arrows are very important. So these kind of arrows. Okay, so you can only put the cutting plane line here on the complete view, but you can't indicate it here. It is not acceptable. So for the arrow bit, I'm going to use what we call a polyline. I'll show you how to draw an arrow using a polyline, and also I'm going to activate nearest because I want it to start from a nearest point here. Okay, polyline. So some nearest point here, I'll draw an arrow. So just click, and then before I go ahead, I'm going to choose width. Okay, so width. So now starting width, I want it to be 0. So 0, then press enter. Then you want your ending width to be maybe 4. Okay, so 4. Yeah, so you'll be able to draw that arrow. Okay, I need to change that line type later on. So yeah, the arrow maybe to that length, and then before I continue, I need to change the width back to 0. So starting width is 0, enter, then ending width is also 0, and you enter. So that is just a line. Okay, so it's that line to that point. So you can click escape if you're done. Now we're going to change this to I just want it to be like that. Okay, I want it to be like that. So what I'm going to do is to simply copy, and I'm going to copy this point to that point, to somewhere there. Okay, then I'll also paste it there. Then what I'm going to do is to rotate it. So simply type RO, then enter, specify base point, this, then yeah, then I'm going to move this. We could just copy it, just copy, specify base point, this, now put it here, nearest point there, and I'll put another one, nearest point there, and escape. So, and get rid of this. Okay, so we can add the text X, so just go to annotate, style, and so on and so on. Okay, it's okay, just click the multi-line text, and the style is 2. I want it to be standard. Click multi-line text, and I'm going to type, draw out a text area, then type X. Wait, yes, so X. We can move it closer to the arrow. Then same thing, I'm going to just copy it, specify base point somewhere there. So I'll copy it to to that, to there, then I'll copy it to there, and I'll copy it to there, and our drawing is done. Okay, yeah, so this is the cutting plane line, and that is the direction of whatever we need to see. So if we cut through the plan and facing whatever is left, this is what we should see. So same thing here, if we cut through the end, this end, and we look that side, we should be able to reproduce this. Okay, so assuming I'm at the end side, okay, which is the end as seen from which is the end as seen from the right. Okay, the right. Okay, let us use the plan, end as seen from the right. So we're basically just flipping the right part, the plan, to face something like that. Okay, so if we stand here and look here, if this thing is sectioned, then that is our section line. Okay, so same thing, if you stand facing here, we should without this part, then what you're going to see is this. Right, so that is it. And yeah.